All right, so now number 15. These guys are a piece of cake. You're just taking something in radical form, and then you're going to put it in exponential form. And these have great advantages here. Now, you could do this two ways. You could simplify this guy, but it's really just easier to do it like that. Like 7/4 is perfectly acceptable. I wouldn't have it any other way. But you could actually take out 4 of those 7s, so that you'd have x, and then you'd have x to how many are left over? 3. Like you could do it like that, but that kind of looks dumb. So just keep it like this. Yeah, that's nauseating. Okay, I don't like that at all. So scratch that. All right, now here's the only thing that can happen. You gotta watch out for where is the square root. What values are the square root on? And you can see that it's on the a and it's on b to the 5th. And so what you want to do to make sure that these guys do have the square root on them is you just make sure that you put it parentheses. Okay, so we've got a and then b to the 5th. Okay, now you can go a little further and say that a is to the half and b is to the 5 seconds. Okay, this I like. This is what I would prefer. But this is okay as well, because maybe you've got other terms that you could combine and break down. So this is good. This is probably better, and this is probably what you would see on the SAT as a possible answer. Okay, possibly not this guy, even though this was the step to get here. Okay, so we can break that half and give them to each of the variables inside the parentheses. Okay, so now we'll go up to 20 and then we'll stop. And let's see if we can go up to 22. Those are kind of relatively quick. All right, I think I did one of these, and I did 20. Okay, so I did 20 with you guys already, so I'm going to cross that out. This guy right here is k. All right, now when I have the same base and they have exponents, I add the exponents. Okay, and so in order to add two fractions, obviously they need to be the same denominator. So I'll have k 11/12 plus, let's add, now let's change the 3 to a 4, so that would be 28/12. Okay, now those guys have the same common denominator, and that would give us 39. Let's write the k first. K 39/12. 39/12. That would be, yeah, k 39/12. I hope the answer key doesn't say something else, because this is actually perfectly fine. Oh no, they want simplest radical form. Okay, so simplest radical form means then that I have to think, I'm actually taking the 12th root here. Okay, but the thing is I can actually take out 2 pairs of k's, because 12 times 2 is 24, so I can take out 24 of those k's. And what's left is, if I take out 24, there's going to be 15. There'll be, no, not 15. 20, geez, I can't, I'm so tired. Is that right? Yeah, but then I could take out another 12 if there's 15. So what am I doing? Taking out, oh my God. Sorry, I didn't mean to stare at you. I'm staring at myself. I can take out 3, and then I'd be left with 3 in there. Okay. I can take out 3 batches of 12 Ks. Okay. So this is our guy right here. And yeah, that's it. So actually, I'm going to write this out. I apologize. There we go. Okay, that would be our final answer there. Okay, so now this is a little tricky too, because you might think that this is the answer, right? And x, but it's not. What we want to make sure that we do is make sure that we make 64 go to the 3rd, as well as x going to the 3rd root as well. And so this guy I can actually break down. The third root of 64 is 4. Okay. And we are taking the third root of 8x's. So I can take out 2 pairs. Now remember, I'm doing this because it says simplest radical form. I can take out 2 triples, not pairs, 2 triples, and I'm left with 2 on the inside. So as long as this number is smaller than this guy, I'm okay. I'm done. All right, so 4x squared, third root of x to the second power. Okay, I don't, now this guy. Where we at? 5 minutes. So this one is, that is 6 to the first power. So what I've got is, I've got 6 to the 5 over 2 minus 1. Okay, because if they are above each other, we can just subtract them. Okay, now if it ends up being negative, then that means it was bottom heavy and then it stays in the denominator. This guy's actually going to be top heavy, so our result will be in the numerator. So let's give this guy 5 over 2 and minus 2 over 2, and that would be 6, 3 over 2. And so this means that 6, okay, is taking the square root of 6 to the third power, okay, which means I can take out a pair of 6's, and I will be left with a 6. Okay, so the final answer is 6, radical 6. Okay. We'll do these two. All right. Square root of negative 98. Now, if the negative sign makes you uncomfortable, it should. Okay. Because you got to just take out the I and just make it standard procedure. You know, those of you that are interested in going further in math, like, man, I'm telling you, the complex numbers will blow your mind. They will blow your mind. They're so incredible. But, you know, we're not going to go there, so you get to just see a little bit of how they act, but I'm telling you, they're pretty awesome. All right, now I'm actually going to try to break this down. I feel like there's a 32 in there. Nope. Is there a 16? Nope. 98. Is there a 4? Nope. 98 divided by, shoot, man, 9? Dude, 98 divisible by any of these? Not 25. 36? 98. You guys get to watch me struggle. That's awesome. No, it's not 64. Are they in, what other? 16, 25, 36. I already did that one. Man, it's 98. Is 98 a perfect? Were you screaming at the screen? You should be. You should have been. I forgot 49. I went all around 7 squared. Such is the struggle. Okay, so this pair of 7s is coming out, and we've got an I there, okay? So our final answer is 7i radical 2, okay? All right, let's move this guy over here. Still recording. This will be the last one for this video. So now here, let's see, we've got a 4. We're going to take out a pair of 2's, okay, because that is 4 times 6. And we're going to take out a pair of 2's, but we're also going to take out the negative sign. Okay, we're going to take out the negative sign, so 2i, and we have 6. And then we're going to multiply by, going to take out also a pair of 2's and a negative sign, but we will be left with 2. Okay, so this is converting it to this. Cool. Now we still have to multiply. So we end up with 4i squared times radical 12. Okay, now in I squared is just -1, so -4 radical 12. Now you can just see there, you see how the negative sign came out as an I as a placeholder, and then he was able to unravel there. So we were able to take out the negative sign. It came back to us. The I became a placeholder, and then it came back to us as a negative sign once we squared it. So now we've got 4 and 3. A 2 is coming out, so that would be -8 radical 3, and there is actually no I for that one. Okay, the i's cancel out. All right, and that's it for this.